You sit down in the interview room, and the prompt you receive is intentionally vast and vague. Design a newsfeed system. Many candidates fall into a specific trap right here. They assume the interviewer is testing their ability to produce a flawless, correct architecture from memory in 45 minutes. This is the Jimmy anti-pattern. Jimmy rushes to the board to prove his knowledge, sketching out rigid schemas without asking a single clarifying question. Jumping straight into schema design without understanding the constraints is an immediate red flag. It shows a tendency to over-engineer, prioritizing design purity over the actual requirements of the problem. The true objective of a system design interview is to simulate collaborative engineering. It tests how you navigate ambiguity, analyze problems, and communicate your reasoning step by step. To navigate this, you need a sequential framework to anchor the conversation: scope, high-level blueprint, deep dive, and the wrap-up. We will use this exact framework to trace the path of an architecture as it scales from a single user to 10 million daily active users. We will demonstrate how a rigorous process ensures that a design can actually survive the transition from a local server to a global network. Step 1 is understanding and establishing scope. This is where you extract the specific physics of the problem from the interviewer. For our newsfeed, that means identifying our specific constraints: 10 million daily active users, reverse chronological sorting, and support for media files like images and videos. Step 2 is proposing a high-level design. We begin with the fundamental bedrock of all web requests. A user accesses a domain name, the DNS resolves an IP address, and an HTTP request is sent directly to a single web server to render the page. This setup has a hard mathematical limit. You cannot add unlimited CPU and memory to a single machine as traffic grows. The first required architectural pivot is physically decoupling the traffic handler from the data storage. Separating the web tier and the database tier allows us to monitor their distinct bottlenecks and scale them entirely independently. Removing single points of failure provides the baseline for scaling any distributed network. Now we enter step 3, the deep dive. We focus first on scaling the web tier to handle millions of simultaneous connections. Buying bigger servers, vertical scaling, has a clear hardware ceiling. If that single web server crashes, the entire application drops offline. Horizontal scaling is the standard solution. We use a load balancer to manage a pool of web servers, distributing requests evenly. If a hardware failure takes a server offline, the load balancer instantly reroutes traffic to the remaining healthy servers. This stateless architecture allows the system to dynamically add or remove servers based on active traffic spikes. Scaling horizontally shifts the engineering challenge from hardware limitations to traffic orchestration. We now pivot the deep dive to the data tier. This requires choosing between relational SQL databases and non-relational NoSQL options. A news feed requires rapid, unstructured access. A key-value NoSQL store can handle these read and write patterns with much lower latency than a traditional relational table. However, in distributed systems, network partitions are inevitable. Data must be replicated across multiple nodes to maintain parity. When a node is suddenly isolated from the rest of a cluster, you must choose your compromise. You either halt the system to maintain strict data consistency, or you keep it available to users while accepting the risk of reading stale data. Perfection is physically impossible in these environments. Engineers must intentionally choose their compromises based on product requirements. This schematic integrates these tier solutions. When a user publishes a post, the request travels through the load balancer and into the web servers. A fan-out service then duplicates that post, pushing the data into the caches of every connected friend. Caching layers are placed in front of the databases to ensure that massive read-heavy loads are served from memory rather than hitting the disk. We also address edge cases like malicious inputs, using checksums to detect and kill infinite spider traps from web crawlers. Decoupling these independent services ensures that a spike in one area does not destroy the entire system. Finally, we reach step 4, the wrap-up. This is an evaluation of how you review your own engineering choices. A common mistake is claiming your design is finished or without flaws. You must be able to point out your system's current bottlenecks before the interviewer does. You should forecast the next failure point, identifying exactly what component will break when traffic grows from 10 million users to 100 million. Mastering these foundational components, load balancers, caching, and stateless tiers, allows you to build and scale any modern application. Ultimately, you are being evaluated on your maturity as an engineer, specifically your ability to build, break, and defend a complex system alongside a team.